Moving on to number 2. Name 2 elements that form compounds that can be exceptions to the octet rule. Now, name 2 elements that form compounds. So we're not asking for the compounds here. We're asking for 2 examples of elements that can be exceptions to the octet rule. Now, there are more than 2, but there are 2 specific ones that we've talked about throughout this section, sections 1 and 2. One of them is hydrogen. It's an exception to the octet rule because n equals 1, that particular principal quantum shell is completely full with 2 valence electrons. Only 2, right? It's satisfied with a duet. So this is an exception to the octet rule. The other one that we looked at during the notes was boron. Okay, boron only has 3 valence electrons and can only form 3 bonds. Once you're sharing that many electrons, you're only up to 6, right? So you are not forming a full octet, even though boron can only form 6. So these are 2 elements that can form exceptions to the octet rule. Some other ones that can form exceptions to the octet rule, beryllium, phosphorus, sulfur does quite a bit, and then xenon. We get some noble gas action going on there, but again, those are a little bit down the road for you chemistry students. The 2 that we've looked at so far, hydrogen and boron. So on to number 3. Explain why resonance structures are used instead of Lewis structures to correctly model certain molecules. Now, when you look at the way you draw a resonance structure versus a Lewis structure, they look pretty darn similar, except for that there's 2 Lewis structures in a resonance structure. Now, in this particular course, you're not going to have to draw a whole bunch of different resonance structures. You're simply going to need to be aware of why it might be necessary. And the reality is that resonance structures represent certain molecules more realistically than Lewis structures. Okay? And that has to do with the delocalization of electrons. That'll be something that we look at a little bit more in depth when we talk about metallic bonding in section 4. But in terms of why resonance structures are preferred sometimes instead of Lewis structures, resonance structures show that one Lewis structure cannot correctly represent the location of electrons in a bond. Now pay attention to what we're saying here. Resonance structures show that one Lewis structure cannot correctly. Look at the resonance structure. It's 2 Lewis structures, right? And so we're representing this delocalized electron or delocalized electrons by simply drawing 2 Lewis structures. So what resonance structures do for us is that they show delocalized electrons, while Lewis structures depict electrons in a definite location. Okay? And that's the real difference. Okay? They're both useful. They're both highly important, very necessary for understanding chemistry at a high level. But the difference is that Lewis structure basically telling you, like, yeah, the electrons are definitely right here. They're always right here, which isn't always necessarily the case. In certain structures, certain electrons are actually delocalized and they move around. And in those situations, we need resonance structures.